Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Welcome back to the deep dive. Today we're sort of peeling back the layers, looking at the fundamental structure behind almost every really big, complex application you interact with daily. Think buying something on Amazon or booking travel, like through Make My Trip, or even Indian Railways, IRCTC, that kind of thing. Yeah, we're talking N-tier and multi-tier architectures. And our mission today, it isn't just about definitions. We want to understand the thinking behind it, the structure. So we'll quickly unpack what N-tier actually is, why these big companies really rely on it for stability and scaling up, and crucially, how separating these architectural layers really change the game for building enterprise software.
Yeah, and that separation is absolutely key. At its core, an N-tier application, it's basically a program that's distributed, right? Spread across, say, 3 or more separate computers, all connected in a distributed network. It's really the standard way, the industry-proven model that tackles those big challenges. Scale, security, fault tolerance, making code reusable, and really importantly, maintainability, especially when you've got tons of traffic. You just can't run something massive like Salesforce or Make My Trip effectively without this kind of structure.
Right. It's like instead of one person doing everything in a tiny kitchen, you have a whole restaurant set up.
Yeah.
Front of house staff taking orders, someone in the middle making sure the orders follow the rules, the menu, and then the kitchen crew actually prepping the food. Everything has its specific job.
Yeah.
Okay, so before we get into the specifics of like the 3-tier setup, let's just quickly nail down the basic building blocks that make all this possible. When we say N-tier, that N just means a number, right? It could be 2-tier, 3-tier, 4-tier, whatever. But they all live inside a distributed system.
Exactly. A distributed network is, well, requirement number one. And this isn't just, plugging 2 computers together. It's a network where different parts, maybe on totally separate machines, work together just by sending messages back and forth. And the cool part is, even though it might be super complex underneath, to you, the user, it just feels like one single system. Think about a big office network, right? Loads of client computers connecting to central high-speed switches and servers. That's the idea.
Okay, so the distributed network is like the highway system. Then you need traffic rules, right, to keep things flowing properly. That sounds like where the client-server architecture fits in, that basic request-response setup.
That's it precisely. It's the fundamental model. The client, that's the program you're using, asks for something, a service, and the server, some program running elsewhere, handles that request and sends back a result.
Like an ATM. That makes sense.
Yeah, the ATM machine itself is the client. It gives you the screen, the buttons. It sends your request, like, give me $200. And the bank's main system, the server, figures it out. It checks your balance in that huge customer database, tells the machine to spit out the cash. Classic client server.
And a key part of N-tier is that these different pieces can run on different kinds of systems.
Yeah.
That's the platform idea.
Exactly. It's not just about Windows versus Mac anymore. In big companies, you might have parts running on an old mainframe, some in Linux containers, others on Windows servers, and they all need to communicate smoothly, usually using standard ways of sending messages. The platform is just the hardware and software environment it runs on.
Right.
And underpinning almost all of this, somewhere, is the database. That's the organized collection of all the important information. Could be MySQL, SQL Server, Oracle, whatever. The whole point of the architecture, really, is to get data into and out of that database reliably and securely.
Right. So with those pieces, distributed network, client-server, platform, database, we can now zoom in on the most common setup, the 3-tier architecture. You hear this one talked about all the time in enterprise software. And the key, as you said, is that these aren't just logical layers. They often run on physically separate machines for that real distribution.
Yeah, absolutely. Let's maybe use a simple example to make it clear. Imagine a student filling out an online form, name, address, email, maybe uploading a photo. We can trace how that information flows through the 3 tiers. So tier 1 is the presentation layer. This is the UI, the graphical interface. It runs right there on the user's computer or, in their phone's browser. It's main job. Just show the form, collect the input, the name, the address, and then pass that data down to the next layer. What's important here is that this layer has almost zero business logic. It's just about the look and feel, the view, and grabbing the initial input. It's like the greeter at the door.
Okay, so the presentation layer is the greeter. Then layer 2, the business logic layer, that sounds like the manager who actually decides if the student's information is okay. The brain, you called it.
Exactly. And because it is the brain, it's also the main security guard and the rule enforcer. This layer usually lives on a central server, an application server. It's the crucial go-between, the mediator, sitting between that user interface and where the data actually gets stored. All the important rules live here. Validating data like, is that email address actually formatted correctly? Is the student ID already in use? Performing complex calculations, deciding the workflow, how should this data be processed or inserted? It all happens here.
Ah, okay. And that's the real power, isn't it? Central control. So if some rule changes, maybe a new government regulation means you need a specific ID format, you only change it in one place, right? And in that business logic layer.
Precisely.
And then instantly, every single user, no matter if they're on the website or a mobile app, has to follow the new rule. That must be huge for things like compliance.
It is huge. You update it once, centrally, and it applies everywhere. That consistency is vital. And only after this business logic layer has done its job, validated the data, processed it according to the rules, structured it correctly, only then does it pass the request down to the final layer, which is layer 3, the data access layer.
Correct. The data access layer. This typically runs on the server that manages the database itself. And critically, it only takes instructions from the layer directly above it, the business layer. It never, ever talks directly to the user's screen.
So what's its job then? Just talking to the database.
Pretty much. Its core function is execution. It gets a validated request from the business layer, like add this new student record, and translates that into the specific language the database speaks. So it might execute in SQL query, like insert into student values or select from student where student ID. And keeping this separate is so beneficial. It lets developers build systems that are reusable and super flexible. Think about it. If you decide to switch your database from, say, Oracle to something else like PostgreSQL, you only have to change this one layer, the data access layer.
Exactly. The business logic layer, with all its complex rules, doesn't need to change at all, ideally. It just keeps sending the same kinds of requests.
Wow, okay. That's a massive advantage. It means a company isn't totally locked into one database vendor forever. They can actually switch technologies without rebuilding everything.
Okay, so the 3-tier model makes a lot of sense for complexity and flexibility. But you mentioned other tiers, like 2-tier. If that middle business logic layer is so important for rules and security, why would anyone build a system without it? What's the 2-tier architecture?
Well, the main reasons are usually initial speed and simplicity. The 2-tier setup is basically just that client-server model we talked about earlier directly. The presentation layer, the client application, talks straight to the data layer, the database server.
Yeah, so no middleman.
Right. No dedicated business logic layer sitting in between. And that's the catch. Any business rules either have to be coded into every single client application, which is a nightmare to update consistently, or they get embedded directly in the database itself, maybe as stored procedures.
And that limits flexibility, right?
Yeah.
And probably doesn't scale well.
Exactly. It makes the database do work it wasn't really designed for, and it's harder to scale just the logic part independently. It can work okay for simpler applications, maybe on a local network with just a few users, but yeah, it really struggles under heavy load or when requirements get complex. It doesn't scale well for enterprise needs. Okay, so 2-tier is simpler up front but causes headaches later. Then there's the absolute simplest, 1-tier architecture. What's that? Yeah, 1-tier or single tier is basically monolithic. Everything, the presentation, the business logic, the data storage, it all runs together on a single machine in a single application. Think of just running a standard application on your personal computer. Everything it needs is right there.
Self-contained.
Totally self-contained. It's the easiest to deploy initially, of course, but you get zero benefits of distribution, no scalability, no separation of concerns in practice.
Makes sense. So we've established multi-tier, especially 3-tier, is the way to go for serious applications because it helps manage all that complexity. But managing complexity itself isn't easy. It must come with trade-offs. What are the big pros and cons teams need to consider?
Right, there are definitely trade-offs. The advantages are compelling, which is why it's so widely used. You get huge scalability. Need more processing power for business logic. Just add more servers to that middle tier. Need faster database access. Scale the data tier. You get much better data integrity because all the rules are enforced centrally in the business layer before anything hits the database. You get massive reusability. That business logic can serve a web app, a mobile app, an internal tool all at the same time. And security is definitely improved security because the database is shielded. It's not directly exposed to users. Plus, improved availability, usually. If one layer has a problem, it might not bring down the entire application.
Okay, those are pretty significant upsides. What's the downside then? What's the cost? Well, The cost is mainly in two areas: increase in effort and increase in complexity.
Because you're splitting things up, potentially across different machines and adding these layers of communication, it just takes more effort to design, build, deploy, and test everything. And managing that distributed system, debugging problems that might span multiple tiers, it's inherently more complex than a single monolithic application. You trade that initial simplicity for long-term power and flexibility, and that requires more skilled people and careful management.
Yeah, a necessary trade-off for anything large scale, I suppose.
Yeah.
So if you're a developer or an architect working with these N-tier systems, managing that complexity becomes the job. Our sources had some really practical tips for dealing with this. The first one sounds crucial for keeping that flexibility we talked about. It's about trying to decouple the layers as much as you possibly can, keep them independent.
Absolutely. Decoupling is key. Think of it like using standard plugs and sockets. If your presentation layer plugs into the business layer using a well-defined standard, you can swap out the presentation layer later without messing up the business layer. Using things like standardized message formats, maybe SOAP XML or RESTful APIs with JSON, helps enforce that clean separation.
Okay, standard interfaces between layers. What else helps manage the complexity, especially between the business logic and the data?
Well, that interaction can get very detailed, mapping business objects to database tables. So another great tip is to use automated tools, things like object relational mappers, ORMs, like Entity Framework in the .NET world, or Hibernate in the Java world. These tools can automatically handle a lot of that complex translation and data mapping between your business logic code and the database structure. It saves developers from writing tons of repetitive, error-prone data access code.
Code generation, basically, for the data plumbing. That
Yeah.
must save a lot of time and headaches.
It really does. And another point, especially if you have multiple different front ends, say a web app and a mobile app, is to maximize code reuse. If there's common logic or utility functions that both front ends need, don't duplicate it in both presentation layers. Put that common code into a shared library that both can use. Keep it DRY. Don't repeat yourself.
Right, centralize common functions too. And one last tip mentioned performance. These layers talk over a network, which can be slow.
Yeah, network latency between tiers can definitely become a bottleneck. So a common performance enhancement is to add a cache layer. You can strategically place a cache, maybe within the business tier or even as a separate tier, to store frequently accessed data temporarily. This means requests can often be served from the fast cache instead of having to make a slower round trip all the way to the database every single time.
Makes sense. Store common results closer to where they're needed.
Exactly. So if we kind of wrap this up, the big picture here is that N-tier architecture isn't just about wiring computers together. It's a strategy. It's about efficiently managing all the moving parts of a modern application, the user interface, the changing business rules, the critical data storage in a way that can actually scale up and stay maintainable. While, yeah, a simpler two-tier system might seem easier at first for anything complex, especially on the internet at enterprise scale, N-tier is pretty much the only practical way to build something robust and adaptable.
So for you listening, what this really means is that this underlying architecture, N-tier, is what dictates how real-world business problems, messy, complex, always changing, get translated into clean, reliable, stored data. The architecture itself shapes how the business process flows through the technology. It's the blueprint for getting the work done digitally. And here's maybe a final thought to leave you with. Think about N-tier not just as a technical design, but as a way of managing change and complexity. It takes a volatile business need a new product, a market shift, a regulation change, and encodes the solution into these distinct, manageable, updatable layers. It's a structure for turning chaos into ordered, maintainable code. So next time you're using some big online service, maybe pause for a second, consider how many invisible layers your request might be passing through and how that separation is probably the only reason the whole thing works so smoothly. It makes you wonder, is the structure of the organizations building these things as well layered and flexible as the software itself? Something to think about.
Hey, yo, haven't you checked out our new book yet? Link in description.
CTSS